Welcome to our business case about Mazda Motor Corporation. To start, we would like to do a presentation of Mazda. Mazda is a car manufacturing company. It was founded in Japan in 1920 by Jujiro Matsuda. 2% of all passenger cars sold worldwide in 2022 were Mazdas. And globally, they had a sales volume of the fiscal year March 2024 of 1.24 million units. 41% were sold in the USA, 15 in Europe, and 13 in Japan. And the revenue was 4,827.7 billion yen, which is almost the same as 31.1 billion US dollars. Mazda has 8 production plants distributed around the world. They have 3 in Japan, 1 in Mexico, 1 in USA, Thailand, Vietnam, and Malaysia. And they employ around 48,685 consolidated employees. Mazda needs raw materials like steel and aluminium to produce their cars. At the moment, their steel mainly comes from Japan, from the 2 largest steel manufacturers, and the aluminium comes from Hiroshima Aluminium Industry Company. Mazda has an in-house power plant in Japan, which contributes to around 80% of the electricity used at the Hiroshima plant. However, Mazda still uses coal to power most of their plants. The Mazda 3 was introduced in 2004. 1,159,509 cars were sold globally from 2019 to 2023. It had an average price of 29,000 US dollars, and the revenue was around 30.47 billion US dollars from 2019 to 2023.
For the carbon accounting, we calculated the carbon footprint of Mazda for the year 2023. For the 2 most sold products, which are Mazda CX-5 and Mazda 3. Both 2 cars are based on internal combustion technologies. In 2023, Mazda sold 354,850 Mazda CX-5 and 178,745 Mazda 3 at global level. Looking into the different scopes, the majority of the emission come from scope 3 downstreams for almost 95% of the total, due to the huge impact that product use has, representing 87% of the CO2 emission, assuming a 20-year usage and 15 kilometers per year. On the other hand, most of the emission of scope 3 upstream come from the purchase of the raw materials. Moving into the different antagonism, despite a decrease of the number of units sold, Mazda emission continues to be very high. The reasons behind this data are several. The first one is the Japan energy mix, which is based for 70% on fossil fuel, mainly coal and natural gas. Then we have the in-company vehicle transportation fuel, and as stated earlier, the big impact that product use has on the overall CO2 emissions. The graph that we can see here shows the current situation inside the company facility and the carbon neutrality goal that Mazda wants to achieve by 2035. The second antagonism leads us to question how Mazda is conducting its innovation process. Most of it is based on incremental improvements. The first one is the energy transition. Indeed, Mazda aims to achieve 75% of its energy needs from coal to liquid ammonia and expanded its solar power use. Then they want to optimize the logistic and the transportation. They want to develop new technology of internal combustion engines to improve fuel efficiency and lower the emissions. And for what regards the transformative change, in 2019, Mazda launched its first electric vehicle, which is called Mazda MX-30, and aims to achieve a global production of this model between 25 and 40% out of the total of its cars. Moving on antagonist number 3, in light of what we have just said, are Mazda assets compatible with the Paris Agreement? The answer is probably no, and the reasons are several. Its improvements for the manufacturing emissions count for less than 1% of the overall company's emission. In addition, the electric vehicle production has a very marginal role, as the MX-30 is not featured in any company reports, unlike higher selling models, making the 25-40% target very complicated to reach. Then we have noted several problems in the electric vehicle production, and probably the reason why these problems have been met are due to the production constraints and the problems in the supply chain.
Let's look at Mazda's exposure to climate change and how it will impact its operations. First, droughts and water scarcity. Mazda's manufacturing heavily depends on water resources for manufacturing processes like cooling and painting, so shortage can disrupt their production, increase their costs, and even damage the reputation if not managed sustainably. Next, floods. These can cause significant damage for facilities, disrupt logistics, and delay production. The financial burden of repairs and downtime could also lead to a loss of market share if Mazda cannot deliver on time. Storms like hurricanes and typhoons add further challenges, damaging infrastructure and increasing insurance premiums. These events could force Mazda to rethink its resource allocation and logistics strategies. Finally, sea level rise threatens coastal facilities, requiring expensive relocations or protective measures, while also disrupting supply chains. Mazda has set 3 key objectives. First, carbon neutral manufacturing by 2035, aiming to make global factories fully carbon neutral. Second, the electrification of its vehicle lineup, with models like the CX-90 plug-in hybrid paving the way. Third, Mazda is driving resource recycling initiatives, targeting a recycling ratio of 95% to reduce landfill waste. To achieve these objectives, the company is focusing on 3 main actions. First, the development of electrified products to meet consumer demand and regulations. The CX-90 PHEV is a strong example of this shift. Second, the implementation of environmental management system across its supply chain, adhering to ISO 14001 standard for sustainability. Third, life cycle assessment help Mazda evaluate the environmental impacts of its vehicles from production to disposal, finding ways to reduce emissions at every stage.
For Mazda to adapt to climate change, they have 2 main vulnerabilities they should address. The first one is the decrease in demand for thermal cars due to climate change and climate awareness. And this would propose a shift in the demand for thermal cars to EVs, which would be vulnerable for Mazda, since their current product portfolio consists mostly of thermal cars. And the second one is the physical risk proposed by climate change, because risks like flooding, drought, typhoons, etc., propose a huge risk, since it can cause disruptions in like the supply chain, or disruptions that could like damage plants or assets of Mazda, and this could hinder the operations. To address this, Mazda should avoid being vulnerable to the decrease in demand by increasing their investments in research and development for EV models and battery technology. This action is aligned with Mazda's real strategy, since they have an aim to have 25% of all products globally being fully electric by 2023, and all other models will be electrified in some form. This action would make Mazda less vulnerable because they would diversify their product portfolio to consist more of electrical products. And to address the physical climate risk, Mazda should take precautions like diversifying their supply chain and product production locations, because at the moment they have a lot of activity in Japan, and this might make them more vulnerable. Therefore, Mazda should consider diversifying their position of production plants and also their position regarding their chosen suppliers. They should diversify those to reduce the impact of climate phenomena in different regions, and they should start maybe focusing more on recycled production materials, because it might contribute with an independence from these Japanese suppliers.
Now we go to the adaptation to the resource scarcity. We have analyzed those that we believe are the three most vulnerable sources due to the supply chain concentration and vulnerability. For instance, lithium, a rare material. Its production occurs for 68% in China. Then we have a problem such as the increased demand and the price volatility due to the expansion of the electric vehicles. We can just think that electric vehicles require 5 times more rare materials than thermal cars. Semiconductors global demand is expected to grow for this reason by 6 times in 2030. Another problem are the geopolitical tension, if we just think to the oil market. Whether for semiconductors and oil, the competition is well distributed among the several sectors, the competition for rare materials such as lithium occurs mainly in the mobility sector, representing 90% of the global market. Therefore, some of the action that Mazda may launch in order to tackle the situation is the diversification of the supply chain and designing of long-term contracts, huge investments in the R&D for the electric batteries, and as we saw here, the investment in battery recycling programs, the acceleration of its electric vehicle production, and Mazda should continue to invest in internal combustion engines, new technologies such as the Skyactiv G and Skyactiv X, in order to optimize the fuels and to lower the emissions.
Now, let's examine the role of Mazda's vehicles in society. First, looking at service needs through Maslow's hierarchy, both Mazda 3 and CX-5 meet fundamental physiological needs by offering reliable transportation essential for accessing food, shelter, and resources. They also address safety needs with advanced features like adaptive cruise control and lane keeping assist. Beyond that, the design and performance of these vehicles tap into esteem needs, appealing to those seeking recognition and a sense of achievement through ownership. Next, in terms of demand and price elasticity, Mazda 3 is more price sensitive due to its affordability and compact size, making it resilient in crises like COVID-19 or energy shortages. The CX-5, being a mid-sized SUV with a higher price point, is more vulnerable to economic fluctuations as consumers might delay their purchase. Finally, in an economy of war, Mazda could pivot its assets effectively, Production lines for Mazda 3 could adapt to manufacturing compact, efficient vehicles for governmental use, such as personal transport. Meanwhile, CX-5's larger platform could make it ideal for conversion into other used vehicles.
In the end, we want to address what Mazda could do to help reduce the CO2 emission level at the society level by 50%. And Mazda's role in society is that Mazda actually contributes to the increase in the emission level in society because they want to sell cars and cars emit CO2. And the majority of Mazda's emissions are the scope 3 downstream emissions because the largest part of the emission happens when the consumers are driving the cars and therefore burn the fuel. Cars account for around 16% of all the total carbon emission from an average French emission footprint of 12,092 kilo CO2 equivalent annually. And this corresponds to actually the largest source of emission from an average citizen. So Mazda really has like a big responsibility together with all the other car manufacturers. And some of the actions they could take to reach this reduction of 50% at the society level was to reduce the emissions. Mazda needs to stop producing thermal cars and focus on EV products. This would reduce the emissions in the scope 3 downstream in countries, especially in countries where electricity is produced with a minimal amount of fossil fuels, like for example in France. And another action would be the production of the cars to include less raw materials that are new, but Mazda should focus on their strategy that they already have of using recycled raw materials in the production of cars, because this could decrease their scope 3 emission upstream if they get the materials from a distribution or a supplier. As an example, this could the use of recycled steel could reduce the emission in kilo CO2 equivalent per ton of steel from 2,211 kilo per kilo CO2 equivalent per ton to 938 kilo CO2 equivalent per ton. And for aluminium, it could reduce from 7,803 kilos to 562 CO2 equivalent per ton of aluminium. A third action would be that Mazda should stop using coal or natural gas to power their manufacturing machines today. By changing the source of power, they could decrease their scope 1 emissions. But even if they did all of these above 3 things, they would still not contribute enough to reduction of the CO2 emission to reach the 50% reduction, and therefore they would need to reduce the production of the volume to actually stop producing as many cars. Thank you.